This lesson helps you understand more about relations and functions. You'll learn about the different ways to define or represent a relation, how to find the domain and range of a relation, and how to determine whether or not the relation is a function. A relation is a set of ordered pairs of x and y. The first number of each pair is the input x variable, called the independent variable. The second number is the output y variable, called the dependent variable. The set of all input x values is the domain of the relation, and the set of all output y values is the range. A relation is a function when each element of the domain is paired with or related to only one element in the range. The simplest way to define or represent a relation is to list the set of ordered pairs. Here's a set of ordered pairs in roster notation. The set of all the first numbers of each pair is the domain of the relation. The set of all the second numbers is the range. To determine whether or not the relation is a function, look to see if elements of the domain are repeated. In this example, the number 3 is repeated. So the element 3 of the domain is paired with more than one element in the range, and the relation is not a function. Notice, when you list the domain or range, don't repeat elements. Here's another example of a list of ordered pairs. The set of all the first numbers of each pair is the domain. The set of all the second numbers is the range. Since none of the elements in the domain are repeated, the relation is a function. You can also list the ordered pairs in a table, either as a vertical table or a horizontal table. The set of all the x values is a domain of the relation, and the set of all the y values is the range. Since none of the elements of the domain are repeated, the relation is a function. Another way to define or represent a relation is with a mapping diagram. The elements of the domain are listed on the left. The elements of the range are listed on the right. Arrows indicate how elements of the domain are paired with elements in the range. Since elements in the domain are paired with more than one element in the range, the relation is not a function. Here's another example of a mapping diagram. The elements of the domain are listed on the left. The elements of the range are listed on the right. Since each element of the domain is paired with only one element in the range, the relation is a function. Notice different elements in the domain are paired with the same elements in the range, but it's still a function. Another way to define or represent a relation is with a graph. Each point on the graph is a visual image of an ordered pair of xy values. The domain of the relation is where it's defined along the x-axis, which for this example is the set of numbers 2, 4, 6, and 8. The range of the relation is where it's defined along the y-axis, which is the set of numbers 1, 2, 3, 4, 5, and 6. You can use the vertical line test to determine whether or not the relation is a function. If any vertical line passes through more than one point of the graph, the relation is not a function. Notice, this relation fails the vertical line test at x equals 2 because the vertical line passes through 2 points. The relation also fails the vertical line test at x equals 4. So this relation is not a function. Here's an example of a relation that passes the vertical line test. No matter where you draw a vertical line, it passes through only one point of the graph. This relation is a function. Up to this point in the lesson, the relations and functions have been discrete. That means the relation includes only these individual points and not any of the points in between. On the other hand, if the graph is a solid line or a curve, the graph includes all the infinite number of points on the line or the curve. These are continuous relations. For this relation, this arrow means the graph goes on forever in that direction. The relation is defined everywhere along the x-axis to the right of x equals 2. So the domain is described in set builder notation with an inequality, x greater than or equal to 2. Along the y-axis, the relation is defined everywhere above y equals 3. So the range is y greater than or equal to 3. Since the graph passes the vertical line test, the relation is a function. For this relation, it's defined everywhere along the x-axis between 1 and 7. So the domain is described with the compound inequality x greater than or equal to 1 and less than or equal to 7. On the y-axis, the relation is defined everywhere between 0 and 6. So the range is y greater than or equal to 0 and less than or equal to 6. Since the graph fails the vertical line test, the relation is not a function. Finally, a relation can be defined or represented by an equation. For example, this equation has a place for an input x value and an output y value. If you select values of x and calculate values of y, you can create a set of ordered pairs. For example, for x equals 1, y equals 2 times 1 plus 3 equals 5. So you have the ordered pair 1, 5. For x equals 2, y equals 2 times 2 plus 3 equals 7. And you have the ordered pair 2, 7. You can continue this process and generate as many ordered pairs as you want. Relations defined by equations will be described in another lesson. This lesson helped you understand more about relations and functions. You learned about the different ways to define or represent a relation, how to find the domain and range of a relation, and how to determine whether or not the relation is a function. This lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.